majority is 2 and 3 and 4, so we'll do those 3. And then we'll go through the SOL review, some Desmos things, talk about the next one, and then go on with word. So with number 2, remember that translating is not something you can do in Desmos. That is something you have to know how to do. So to translate this expression, 4 less than a number, cubed plus 3. There are 3 operations that you need to include. The 4 less than a number is going to be at the end of this part. Because of the commas, this is certain things are placed in separate ways. So 4 less than a number, comma cubed means all of this is cubed. And then at the end of that, plus 3. If it had said 4 less than a number cubed with the comma after that, then the x would be cubed and not the whole thing. So the comma placement matters. Questions on that? Number 3, we want to do in Desmos on the calculator. Then I can see those. To find the line of best fit, I need my y1, the squiggly line, the tilde, mx1 plus b. And our line of best fit, let's put 3 decimal places. Y equals negative 0.503, x plus 15.733. And that would be your line of best fit. Questions there? Alright, and then number 4, if we were to combine the terms, distribute your negative 1 and the 4, so we have negative 8x minus 4 minus x plus 3 plus 6x. Combine all your like terms. So we have negative 9x plus 6x, negative 3x, and negative 4 plus 3 is negative 1. And if you put the original and the final into Desmos with capital X's or change the variable, add the slider, the decimal should be the same. Questions on that one? Did anyone need to see that check method in Desmos? Here are your answers to the SOL review for A6c through 7d. Make sure you have these written down either on a piece of paper or in the packet. If you need another one, let me know because I do have extras. For this one, you really just needed to graph the line. If you looked on Desmos or put this into Desmos, you could have just graphed the line from that, or you could have solved it and then graphed it, but you should have a y-intercept at 5, and then slope points every down to over 1. And then go on to the next one. This page is not something we talked about, which is why it wasn't part of the formatives. But really quickly, as an explanation, it's looking for which of these represents a function. So if each x value has its own y value, it is a function. If it doesn't, if it has two y values, then it's not a function. So 1 was a function, 3 was not, 2 was not, and 4 was. And then on the next page, something else that we haven't talked about, but we're going to talk about a little bit today. Domain is all of your x values. Range is all of your y values. So 5, the range was C. And 6, the domain was D, all real numbers. And then the last two sections, you could have done all of these in Desmos, because you're looking for zeros or x-intercepts. So if you type all of these in, you can find where this crosses the x-axis. So answers for this section, for 7, 2, 0, 8, 4, 0, 9, 3, 0, and 5, 0, it had 2. 10 was 2, 0. 11, 6, 0. And 12, negative 2, 0. 13, it asked which one had 2 distinct zeros, so which one had 2 x-intercepts, which was C. Through 16, again, you could have done in Desmos, and you could write them either way. The zeros or the x-intercepts of 14 were negative 1/3 and 3/2. 15 was negative 1/2 and 2/3. And 16 was negative 4/5 and positive 4/5. And when you finish that, go on to the next page. And then for 7D, that was asking about your x and y intercepts. So for 17, you could have done a couple different things. Put this into Desmos and saw which of these were your x and y intercept. Or looked at just the y intercept. There was only one that matched this y intercept, so D. 18, you had to plot the x and y intercepts, so there should have been 3 points plotted. 19, you had to find which two factors would create this equation, so you could have played around with those, put different ones in, and saw which one graphed that. I will not be checking this section again, so if you did not have this today, it's just going to be a 0. As a reminder, just make sure you do this next one. On Monday, what we'll be doing is the rest of the packet. So 7E we haven't talked about, but you could try it. But 7, 8, and 7, 9 you should be able to do, so those will be the formative sections. Yes?
Is it graded on like completion or like actually getting it right?
I don't have time to check everyone's. Alright, some of these in Desmos really quickly. So all of the ones that asked about zeros, you put that in, find where it crosses. You can find all of those x-intercepts. for the one that asked about which one had two distinct zeros, if I were to graph all of those, I only have one that crosses the x-axis twice. So that is really easy. Put it in Desmos and see. That was for the x and y answer. For the last question, if you would put in the different factors, you would see that it does match up. So make sure you are utilizing Desmos. Try it. Practice that. Make sure you're working on JLabs and Delta Math, all of those things. Okay, so everyone should have notes that looks like this. I want you to write down all of this. So as you're writing, I'm just going to talk through it. So Unit 10 is all about quadratic equations. Quadratic equations are written in the form y equals ax squared plus bx plus c. That's your standard form, ABC order, highest exponent to lowest exponent. When graphed, a quadratic equation creates a U-shaped curve. So we've seen that before, but didn't know what it was called a parabola. To the best of your ability, I want you to draw in these rough sketches. And we're going to talk about some new vocab. So when we graph a parabola or a quadratic, if the a value, the number in front of x squared, if it's positive, your parabola is going to face up. If it's negative, it's going to face down. And then when we graph the quadratic, graph the parabola, it has an axis of symmetry. The vertical line, it's a vertical line that divides the parabola into two equal parts. So whatever you see on one side, it should match on the other. We don't actually see this when we graph quadratic parabolas, but as we're getting used to it, we will draw that in. Does anyone still need the graphs piece? When finding the axis of symmetry, there's a formula that you're going to use. X equals negative b over 2a. And after you simplify that, you get some x equals some number, so that would be some vertical line. And on your axis of symmetry, you're going to have a point. This would be the turning point where it changes direction, basically. It starts going up, but then it goes down, or vice versa. This is your vertex, written in the form x, y, x comma y as an order pair. When your vertex is the lowest point, it's your minimum. And when it's your highest point, it's your maximum. Make sure you have these things off to the side as well. And then we're going to use all all of the vocab, all of that knowledge to first get in the habit of finding the axis of symmetry, finding the vertex, and doing a rough sketch. And then once we get into practice with that, then we'll actually learn how to graph it and find some more characteristics of it. So we're going to do example 1, which is on the same page at the bottom. I'm going to rewrite the axis of symmetry. X equals negative b over 2a. If you want to label your coefficients as a, b, and c, so you know which one is which, you can do that. And then to find your axis of symmetry, you just put whatever those coefficients are in this. So x equals negative 8 over 2 times, what's your a value? That's the variable. What's the number in front of that? 1. So then go ahead and simplify that. What would that give us?
-4.
X equals -4. So make sure you're writing x equals. Then to find the vertex, we're going to put that number into our equation where all the y's are. Make sure you're using parentheses. So as you're doing this, I need to see the setup of these two. Whether you do the rest simplification in the calculator or by hand is up to you, but I need to see this part. So you can either go ahead and put that in the calculator or start to simplify it by hand. What would that y value be? -1. So our vertex would be -4, -1. And then you're going to draw a rough sketch. So draw in your x and y axes. Draw in roughly where your vertex would be. Draw in a dashed line to show where the axis of symmetry would be. And then looking at our a value, it's positive. Would our parabola face up or down? Up. So from the vertex, draw a U shape that faces up. Try to make it symmetric, but it's a rough sketch, so it's okay if it's not. Questions on any of that? How we found any of that? Alright, we're going to do a few more of these and then move on to the actual graph. Go on to the next page. I'm going to rewrite our formula up here so we're not looking back and forth. X equals -b over 2a. And then let's find that axis of symmetry. Again, if you need to label them, you can. How would I set that up? What is my b?
10x.
10, not the x. So -10 over 2 times -1. ahead and simplify that. What would our axis of symmetry be?
5.
X equals 5. And then put that into all of your x values to find your y value. And you can either put that into your calculator or find it algebraically. Well, 2 would be our y value. So our vertex would be 5, 2. Go ahead and draw in your rough sketch. Draw in your axis of symmetry and your vertex. Would this face up or down? Is your a value positive or negative?
Down.
Down, because it's negative. So draw a parabola that is facing down. We're going to do one of these next 4. I'll let you guys choose 3, 4, 5, 6, or 7. Which of those do we want to see do or go over? Because the a value is negative. In the previous one, the a value was positive. So between 3, 4, 5, 6, and 7, which of those do we want to see do go over? Have questions about?
7.
Okay. So let's do 7. Let's find that axis of symmetry. How would I set that up?
24 over.
You can either put negative minus at 24 or just make it positive over 2 times
-1 or 1.
-3. Our a value will change.
Where are you getting the 2 from?
It's part of the formula.
Oh.
So then what would our axis of symmetry be? Negative. X equals -4. And then put that into all your x values. Find that y value. Should not be that high. Make sure you use parentheses. Anyone else get 6? I think it was 6.
Yeah.
Anyone need to see that in the calculator, just in case they weren't getting that? Go ahead and draw in your rough sketch. Would this face up or down?
Down.
2 more from this page and then move on to the actual graphing pieces of it. Do you have any questions on how this process works so far? In number 8, what are we missing? Let's see. Now, in this, that's not going to affect anything. If we were actually using the quadratic equation formula to solve, that would mess up things, but this won't have any effect. So if we go ahead and set up our axis of symmetry, what would that look like? -4 over
2 parentheses -1.
And then what would our axis of symmetry be?
2.
X equals. And then put that into all of your x's and find y. +4. So your vertex would be 2, 4. Draw in that rough sketch. Would this face up or down?
Down.
Down.
And then in number 9, what are we missing there? B. So when you're missing B, you're going to set B equal to 0. So then if I set up that equation, what would it look like?
X equals 0.
That would be the final answer, yes. But still set up the equation, what would that look like? You 0 over 2 times 1. But anytime your B value is 0, your axis of symmetry is going to be x equals 0. Still show the work, but that would be your axis of symmetry. And if I put that in for y, or for my x's to find y, what is my y value?
-3.
-3. So go ahead and draw in that sketch. I'm going to highlight over the y-axis just to show that would be my axis of symmetry. And would this face up or down?
Down.
Is your a value negative? Or would it face up? So knowing which direction it's supposed to face as you start to graph it, maybe you typed in something incorrectly. If your graph doesn't match the equation, you know you did something wrong, something's off. Go on to the next page. Yes. So now we're going to actually graph this, find out how to graph it. Still going to find the axis of symmetry and vertex, but then we're also going to graph this like we should do. So I'm going to rewrite our axis of symmetry formula. And then in example 1, in order to set up my axis of symmetry, what is that going to be? What would our axis of symmetry be?
0.
X equals 0. And then if I put 0 into the equation to find y, what is our y value? Also 0. So our vertex would be the point 0, 0. You're going to put that point in the middle of your table. You can fill out the rest of your x values. You need to go backwards 2 and forwards 2. And then to find your y values, you could do a couple different things. You could put each x value in to the equation and find each y value by hand or in the calculator. I'm going to show you how to do that in the table in the calculator. So in your calculator, go into your y equals, whatever's there, put it out, and then type in x squared. And then go into the table, second graph. If yours did what mine just did, go back into a second window and change that to 0. Second graph. There we go. And then I see the points I just wrote on the table, write those down. Because my axis of symmetry is at 0, that means these points are going to be the same, the y values, on both sides of the axis of symmetry. So 4, 1, 1, 4. And then we're going to plot those 5 points. -2, 4, -1, 1, 0, 0, and then it just repeats. We're not going to actually draw in the axis of symmetry, but you could see where it's split in half. Make your U shape through that. Make sure it has arrows through it, because it goes on forever and ever. And that is how we graph our quadratic equations. You could have more than 5 points, but you need at least 5 points. Questions on how we do the graph piece before I talk about domain and range? Right beside this. Domain is your x values, and we look at our domain from left to right. Least to greatest, moving left to right. Our range is our y values. And we look at that from lowest to highest, or bottom to top. Again, least to greatest. When we write our domain and range, it's going to be in interval notation, but you may also see it in set building notation, so I'll write what that looks like. So domain, you kind of have to imagine, because sometimes you can't accurately see it. If I'm looking at this, I know it keeps going to the left, slightly up and left. It's going to keep doing that off the graph, off the page, forever and ever in that direction. Where would that start? If it keeps going left, where would that start for your x values? Were you raising your hand? Okay. What do we think? If I kept going left on my number line, where am I going to end up? Negative infinity. And then what about to the right? It's going to do the same thing. Keep going up and slightly right, off the graph, off the page, off the board, forever and ever in that direction. Where would it end? Positive infinity. For your quadratics, in this class, the domain will always be negative infinity to infinity. All real numbers. Everything from negative infinity to positive infinity and everything in between, your fractions, your decimals, negatives, positives. The other way you might see this is, so write this, curly bracket, x, just a vertical line, and then x, a weird e. I'm actually going to rewrite this because I'm running out of space. A weird e, and then a double R, like a capital R with another Y in it, and then curly brackets. This reads x such that x is an element of all real numbers. They mean the same thing, negative infinity to positive infinity, but you may see one or the other, and you have to know that they mean the same thing. Questions on domain? So domain will always be the same for us. Range will be different. If we're looking lowest to highest, what's the lowest y value? 0. And you can find that from one of two things. Either look at the graph, you can draw in a line to look at where the lowest point is, or you can look at the vertex, wherever that y value is, it's going to be part of your range somehow. This point is solid, closed, so it's going to be a square bracket starting at 0. What's your highest point?
4.
It doesn't go higher than 4? Infinity. So highest infinity. Or if we were writing it in set builder notation, it's going to start off similarly, curly brackets, y, the line, so y such that. It starts at 0 and it goes above that, so y is greater than or equal to 0. Questions on range? Alright, let's try example 2. Same process. If I'm finding my axis of symmetry, how would I set that up? What is B? 2 over 2 times what's A? 1. So what's our axis of symmetry?
1.
X equals -1. And then put that point into all your x values. Find your y value. What is that y value? Like that. 4. So our vertex would be -1, +4. Put that point in the middle of your table. Fill out your x's, go backwards 2, forwards 2. And then we're going to put this equation into our y equals. Go ahead and do that. table, find that vertex point, and then fill out your your y values. 8, 5, 5, 8. Yes. Yes. And graph those points. This should face up because our a value is positive. Should be symmetric around x equals -1. The y value should repeat on both sides. What's the domain? Yes, it doesn't change. Negative infinity to positive infinity, or x such that x is an element of all the numbers. For our range, what's our lowest point? Y value. What's our lowest y value point? 4. And then it starts at 4, so square bracket, what's our highest? Infinity. Or y such that y is greater than or equal to 4. The point is closed, it's included. If it was open, then it wouldn't be. Okay, let's do another one. And then, any you guys want to do, and then the last thing we're going to do. So let's find our axis of symmetry here. How would I set that up? X over 2, it's negative b, so negative 8, or just 8, over 2 times negative 1. So our axis of symmetry is -4, x equals -4. Go ahead and put that in for all your x values to find y. What is y? -1. I'm going to fill out the x values by going backwards 2 and forward 2. But I want you guys to find the y values. Put that in your calculator, go into the table, find what your y values would be. Like you have them. Okay.
Is negative 5 more than 0?
I don't know off the top of my head. It could be, it could not be. I don't think so. -3 and -2.
Oh, all y values. Like I'm saying the y values.
Okay, which ones?
Can I say all of them? And
I really just need two of them, then it's going to repeat.
-3 and -2.
So then it would be -6, -3, -5, -2. I'm going to say this is not right. To double check those. Was it actually 0? Put it in your calculator, figure it out. As a reminder, you guys won't have Desmos for this on the test, but for the SOL. What were those two y values? Put it in your calculator, figure it out. I'm not going to tell you. After we're done, we have to talk. Did you find the y values? So you guys are waiting on me. I'm not going to give you the answer. Put it in your calculator, find the y values. You're using this equation, put it in your y equals, put it in your table, find the y values. And did you get your y values? Figure those out. How did you get those y values? So if you guys have questions, now's the time to ask.
Is it -5, -2?
That sounds more right. Let's see. Yes, that is right. So if it's not making this shape, something should tell you it's will make you start. Also, use your calculator. That's what it's there for. What's your domain? Negative infinity to infinity. Or x, is that x in all numbers? What's our range? What's our lowest value? Is that our Is that our lowest value? So it's not lower than -5.
It's -1.
So it's not lower than -1.
Oh no, it's -5.
It's negative infinity. Our lowest value keeps going down. It's negative infinity. It switched directions, so our lowest value is different. But our highest value is -1. Since it's everything below -1, that would be y is less than or equal to -1. For time's sake, we won't have time to go over any other questions. So I want you to skip to the page that says analyzing quadratic graphs. Not only should you be able to find those characteristics from graphing it from the equation, but also vice versa. So you have two graphs here. We're just going to kind of compare them. For graph A, what is the axis of symmetry? What is the line that splits that in half? So look at your graph, find where it would evenly be split in half. To the line. Just the line, not the vertex yet. But it would be at this line, so x equals -2. What about for graph B? X equals 3. And then what's the vertex of graph A? So that would be your lowest or highest point on the axis of symmetry on the parabola. Guys, focus. -2, -5. We'll write that point first and then talk maximum. What is the vertex for graph B? Three, four. Would the vertex of graph A be a maximum or a minimum? Right. What did you say? Say it again. It was right.
The maximum?
Sorry, I thought you said minimum. So lowest point, that's your minimum. And then for graph B, next one. And then for 5 and 6, what would the domain of both of these be? Correct. Negative infinity to positive infinity. The range is what's going to be different for both. So for graph A, what's your lowest point? -5. What's your highest point? For graph B, what's your lowest point? -infinity. What's your highest point? Right, and then the last thing, to identify the equations, well, we know graph A faces up, so we can eliminate which two equations? C and D. And then if we were to guess, which one do we think this is, A or B? We're going to check it, so it doesn't matter. B. Okay, so let's put this into our y equals. And then I'm just going to graph it. Does this look like graph A?
Yeah.
Yes. If we did the other one, it would be graphed on this side, and that's how we would know it's not, right? So B is our answer there. And then for number 8, graph B faces down, so which 2 can we eliminate? A and B. Which one do we think this might be?
C.
Okay, so let's put C and then C votes.
Negative. Minus 6x. Minus 4.
Does that look like graph B?
No.
All this Kyle.
Alright, so then for the remainder of class, in the next 15-ish minutes, I want you practicing. What you practice on, you can choose. So you can either keep working on practicing these notes, Delta Math for this week, past Delta Math, this Delta Math that'll be due next week, JLabs, SOL practice. You have a bunch of different things you can be working on. Use this time wisely.